circling back around to some more applications to help us with exponential equations and logarithms. Just a quick review of compound interest. We have our formula and reviewing what each of the variables in the formula will stand for. I always start off with just kind of trying to decide which formula to apply. I plug in anything that's given and then figure out what technique do I need to solve for the missing piece. So when we're looking at how much money should be invested today at 4% interest, compounded quarterly, right away compounded rings a bell. And the fact that they're saying compounded quarterly, I already know that I'm going to apply this particular formula. So that in 8 years, the investment will be worth $15,000. So I always start off, might as well try for partial credit. We always try to write out the formula we are going to use. And we'll decide what we're plugging in. So I see the 4% interest. So 4% interest would lead me to believe that R is the percentage, but we have to write it as a decimal, so 0.04. 8 years, it's going to lead me to believe that that's time. So I got 4% interest, 8 years. The investment will be worth $15,000. So that's letting me know that my future value is $15,000. So let's see, we have almost everyone. The compounded quarterly. So quarterly, that is our N. Compounded quarterly means 4 times per year. So it looks like we are trying to solve for how much money should be invested today. That is our principal. So let's plug in everyone that we know. So F is 15,000. I do not know the principal. 1 is 1. R is 0.04. N is 4. And again, N times T, that is 4. That's going to get multiplied by T, which is 8. So I always like to show what I'm plugging in just in case I make a minor mistake with my calculator. At least there's some partial credit awarded to me if we are being awarded partial credit. I guess it depends what class you're taking. So from here, I'll do a little bit of simplifying. Keep in mind, I still have the 15,000 on the left side. I have P. And, if we're using our TI, we don't have to go too crazy with the simplifying. Maybe the 4 times 8 would be appropriate. So that's 4 times 8 is 32. What's kind of cool when you are using your TI is that you could actually plug a lot of things in all in one shot. I just want to keep in mind that if I'm actually looking for the exact solution to this, we are solving for P. And notice that P is a factor of this expression, 1 plus 0.04 divided by 4, all taken to the 32nd power. This, my friends, is really going to be a constant. Now we can type it into our calculator at the moment, or we can just say, hey, if we were solving for P, to undo multiplication, we're actually going to divide both sides by the constant, which is 1 plus 0.04 divided by 4 to the 32nd power. So technically, you do have an exact form of what your P will end up being. And it's up to you. You may have been inclined to maybe simplify the parentheses to start with. I guess it depends if you have a TI or not. I always like to use the exact values because sometimes we end up with those irrational numbers that we don't want to cut off too soon, otherwise we'll make the problem inaccurate. So let's go back and just kind of show you that when I do solve for P, we divide out. P will equal this statement, 15,000 divided by 1 plus 0.04 divided by 4, all to the 32nd power. So I kind of want to show you what does this look like if you're trying to type it into the TI all at once? So let's switch over. And I'll make sure I'm sharing this with you all. And this is more of something I'd probably just type in my home screen. So I'll get out of this, clear out stuff. And so if I'm trying to type this in, I just have to be really careful with parentheses. So we'll start off with the 15,000. That is a single number. We don't have to really worry about enclosing that in parentheses, but that is the numerator of our expression. Now, here's where we have to be a little more careful. You're dividing by an expression taken to an exponent. So the calculator sometimes misreads things if you don't tell it precisely what order of operations to take. So again, anytime I'm dealing with fractions that have more complicated denominators or even numerators, I will enclose the entire denominator with a parenthesis. So I'll start off. There's two things going on. There is an expression taken to the 32nd power. So there's a double parenthesis. So that'll start with saying that's 1 plus 0.04. I guess you don't need the 0. I'll start off with 0.04. That's divided by 4. So that's the base of our exponential expression. Now we're raising this to the power, the 32nd power. So I would have the exponent key with the 32. Keeping in mind that I need to close off this particular problem. So this is taking care of it all at once. We'll just press equals to figure out what type of answer we get. And you'll notice that we get one of those irrational numbers, never-ending decimal for the most part, or maybe it's never-ending in the sense, but really when we're dealing with money, we're going to figure out what do we round to. So let's go back and write our answer in, and then I'll kind of discuss another way because sometimes different calculators don't understand exponents as well. We just figured out that P is about, I have 10,909. And if I go back just to check, that is 56158. 56158. Now remember, P is the amount of money that you had to invest today to have $15,000 in the future with the same constraints. So if you're really speaking in real life money, we'd be rounding to 2 decimal places, the 100th place. So I'm kind of looking at, well, if I take the 6, that's my digit in question, and the test digit would tell us that we're actually rounding to, that's $10,909.56. So that would be our principal that we have to invest in order to make have the account be worth $15,000 in the future. Now, one thing I'd like to point out, some calculators don't use the exponent form. So let me see if I can just make sure I run with that. Let's see if I can switch back in. Let's see if we can change the type of calculator. If not, I'll just write it in for you. Maybe the TI-84 Plus. No, I think that still has exponent form, so I'm sorry. Sometimes they show me what the TI-83 does, so I guess I'm going to keep that as is, but I'll show you what I'm trying to get at. So let's look at how we're entering that in the calculator. It's more of using the exponent key, and then it doesn't really show up as an exponent. So a little sidebar there. So with your typing in to the calculator, maybe for a TI-83, or sometimes just the 84 that doesn't have the special operating system, we could be typing in 15,000. We would have the division key, and we'd have to kind of keep in mind that there is still that double parenthesis. So nothing's too different, except for I'd like to show you that what you would see in the TI when you are raising something to the exponent, you won't see the exponent, you'll see the exponent key, a little TP, or we call it the caret, raised to the 32nd power, which is then what we would be typing in. So just be careful. No, you probably know how your calculator works already, but if you forget parentheses, sometimes the expression ends up being different than what it's supposed to be. So just take caution. I hope this helps. I will see you in the next example.